Good evening, everybody, and thanks for coming along. I know it's exam time, I think, in the college, so we've been told numbers might be a bit low, and I guess it's the day after the bank holiday, so we're all getting back into the swing of things during the week. I'm going to try and keep this kind of interesting for people, and we can get technical. I suppose if you have questions near the end, and if you have technical questions near the end, by all means bring them up then, and we'll deal with them. But I think other than that, I'll try and keep your interest through the project, because it's quite an interesting project, really. I'm John Lee. I'm an Associate Director with Malachy Walsh & Partners. We're a Cork-based company. We have offices in London, Tralee, Limerick and Cork. We don't have an office in Dublin, but we should. And we're still working on that. But David McCarthy is going to talk about the construction of the project. I'm going to talk about the design aspect, and hopefully we'll kind of blend in together, and you'll see it from both of our angles, which might make it a bit more interesting for you. O'Donnell and Toomey, architects, are the architects on the scheme, and as luck would have it, they're all on holidays this week, so they were invited to speak, but they just couldn't make it. So they've kindly given me permission to use some of their images, which should make things a bit more interesting for you as well. Ardup were the building services engineers, and the client was the Department of Education and Skills. Just to go through what we're going to cover, give you a small bit of background to the project, go through the site location. It's quite an iconic location in Cork city centre, and you can see the site from most parts of the city, certainly Patrick Street and the city centre itself. It's a difficult enough site, and I'll go through the reasons why it's difficult. I'll try and give you some kind of handle on the architectural design, although it's not really my forte, but just to give you some background there. Ground conditions investigations, there was a lot of demolitions and civil engineering involved in the project, which I think suited Keating's particular skills. A lot of temporary works involved because of the intervention on the old listed buildings on the site. So we'll give you some of the background to some of the more interesting temporary works that were completed. A lot of underpinning, ground anchors to keep old retaining walls in place while we excavated very close and in front of old walls. Listed buildings that were kept, and then just go through some of the new buildings. David will talk more about the construction challenges. The project is the redevelopment of St Andrew's College. St Andrew's College would be a very well-known and well-established old all-girls school in Cork city centre, and there'd be an awful lot of goodwill for St Andrew's College, politically even, and I think that was one of the reasons the project got to go ahead at all, because I think if you were to look at it from a cold economic point of view, the project isn't a runner for the amount of money that it needed really to redevelop, given where it is and the particular challenges on the site. It's a 530 pupil college. The design team was appointed in 2000, but it took 10 years to convince the department to spend money on it. Part of the project was the relocation of the pupils out of St Andrew's College to another premises within a mile, which was the old Marymount Hospice on Wellington Road. Sorry, no, there's probably not too many Cork people in the audience, so you might know where I'm talking about. L&M Keating were appointed in early 2014, and we'll say at the moment they're on target for completion October, maybe late October this year. This is one of the images here from O'Donnell Toomey. It's actually a full-scale cardboard model, and it's a fantastic model of the site. It shows the slope of Patrick's Hill on the lower right-hand side, and the lighter cardboard cutouts are the existing buildings that surround the site. This is looking from the south-east up the hill towards the college, and you can see the darker cardboard buildings are the new and existing buildings, and really the site is very, very stepped due to the steepness of the topography, and it was a real challenge for the architects to try and fit in all of the square area that's needed for a college of this size and work within the department's area schedules to convince them that it could be done to a modern standard. It's a prominent south-facing site, and you can see there's buildings on the south, which is lower left-hand corner, buildings the whole way up the east side of the site on Patrick's Hill. There's a public road on the far side, on the west, and there's a private property very tight to the northern boundary of the site as well. Just to give you a feel for where we are in relation to, that's Patrick Street, the main thoroughfare, the main commercial heart, if you like, of Cork City Centre. And the site is visible from pretty much most of the city centre. So, you know, I think the architectural design and the finished product really was very important to get right. And the architects worked very hard to do that. Again, just to give you another sense of the tightness of the site and the slope of the site. Patrick's Hill is on the far side. The buildings there, just running up here, and this is Richmond Hill on that side. So that you can see the site and the neighbours were all, you know, I suppose communication during the design development phase was very important for the design team to get right, because if you didn't get on with your neighbours here, the project wasn't going to be successful. And I think to date we've managed that between us all. Again, the red line is showing the site boundaries, and you can see you're either straight onto a public road, a steep public road, or you're adjoining a party wall, a boundary wall with a neighbour. Site constraints and challenges. Access onto the site is via a 4 metre wide, at its widest 4 metre wide road straight off Patrick's Hill, where the hill is at a slope of 1 and 4, so it's an extremely steep part of Cork City. So getting onto the site, David will go through that in a minute, has proved very challenging, and even in terms of site investigations and everything that had to happen during the school academic year, it made things very difficult. All the boundary walls are old listed masonry walls, random rubble masonry walls, most of which had no foundations at all under them, and part of this project was required that we would dig up to 6 metres, I think was the deepest excavation within a metre of these walls that had no foundations under them. And these walls aren't owned by our client, they're part owned by our client. So the party issues and the third party property owner issues were very important to get right. The listed buildings, there are 4 buildings, they're shaded on this sketch here, and those buildings were kept during the construction and have been amalgamated into the overall design of the site and final use of the site. So the project really, you know, involved civil engineering in terms of excavation and underpinning, I suppose careful restoration of existing listed buildings, which had the conservation officer and the city council, I suppose he was carefully involved as well at times in terms of just agreeing with him the detail of how we would do that. And then finally new build, you know, contemporary new in situ reinforced concrete buildings, framed buildings, finished to a very high standard of finish. So we'll go through that later on. There's a PE hall with a playing surface on the roof, and you know, there was a bit of negotiation with the department. They have a rule, as I understand it, where only 10% of the roofs can be flat roofs. So we had to convince them it wasn't a flat roof, it was a playing surface. So that took a while to convince. But all of the other new roofs are pitched roofs on the site. There's a 4-storey science block, which goes to 6 stories actually. It has 2 below the ground and 4 above the ground in one part of the site. There's a new arts block, which is between 1 and 4 stories, again 2 under the ground and 2 above. There's an escape stairs building. There's link bridges between new buildings and old buildings. And there's the alteration and upgrade of the 4 listed buildings, as well as in external works. They're the main, if you like, engineering elements of the project. Just to show you where the listed buildings were located on the site, this is looking from northwest, so Patrick Street would be over to your right as you're looking at that photograph of the cardboard model. So we've coming from the top. You have a small gate lodge, which was listed, into which we put a disabled enabled lift to bring disabled pupils and staff from a new car park that was formed through the old wall onto Patrick's Hill, down to a Part M enabled access into the school. The DAC on this project was a real challenge, and we certainly weren't involved in producing that, but it took an awful lot of work to get the DAC right, given the slopes on the site. There's the convent building, which was the old nuns' residence, and the nuns is the Ursuline order in Cork. They're an old order who've had this site for over 100 years. They agreed to pass on the convent and the property free gratis, on the basis that the department would develop the site, and that was one of the important aspects to getting the project up and running and getting agreement of the department. There's the main school, which is about 160 years old, which is quite a high, slender, tall building bounding the west edge of the site. And then there's what's known as the high school, which is about 100 years old, or a bit more, maybe 120 years old structure down the southwest corner of the site. The new buildings and external works essentially split into those sections. You can see there the new entrance from Patrick's Hill, incorporating a car park and new retaining walls, a 4 to 6 story science block, P hall with external playing area on the roof, the arts block, which goes from the very back north edge of the site and steps down over a number of levels to meet the back wall of the old main school. There's a basement under the courtyard to the front of the old main school, which links the PE hall, the science block, and the high school underground. There's changing areas in that basement, and then there's an escape stairs block for fire escape purposes leading straight to the public road in Richmond Hill. Just another view from the southeast, showing how all the buildings fit in together on the site. To give you a feel for the slope, there's a 17 metre level drop from the back of the site to the front of the site, which works out about 1 in 6 or thereabouts through the project. And there's essentially 5 different areas where there's a substantial level drop as you go from north to south through the site. There's a dashed line. I'm sorry, I don't have a pointer with me now, but there's a dashed line there that you can make out. That's the level of the rock, which is a siltstone sandstone rock. Cork has 2 types of rock. You've got red sandstone on the north side of the River Lee, and you've got karst limestone on the south side of the River Lee. And we're literally a couple of 100 metres on the north side on the escarpment that forms the northern edge of Cork City, that you can see right as you go into Cork from the Dublin Road. You see it right from Tivoli, goes right through until through to Sunday's Well and the Lee Road. So all of Cork, the north edge of Cork is formed on this cliff, if you like. So we in places we were digging out rock up to 4 or 5 metres, and in other places our foundations were 3 or 4 metres above the rock level. So that in itself was a challenge in terms of differential settlement for new structures on the project. And we'll explain how we overcame that. Ground conditions and investigations. There were 17 shell and auger boreholes, which gave us information on the overburden. We were very interested in getting good information on the rock, on the bedding and strike planes, in particular because we wanted the contractor to understand what would be needed for breaking out the rock. We were concerned with regard to excavating close to old listed buildings and shared boundary walls where there's neighbours on the other side. If you got that wrong, you're pulling out a lump of rock, and next thing the wall comes with it because you haven't been able to control how much rock is coming away. So we put a lot of work into getting the site investigation right and trying to explain that to the contractor at tender stage. Typically you had 2 to 4 metres of cobbles and boulders over moderately strong siltstone, sandstone. We put in piezometers to look at groundwater. We did hit a couple of ground wells when we dug out in certain parts of the site. No water was really encountered during the site investigation phase, so we just had to deal with localised springs that we came across during the construction phase. We did a full geophysical survey looking at all the old services and anything under the ground. CCTV surveys, timber surveys, window surveys, and asbestos surveys. There was a reasonable amount of asbestos had to come out of the job, and all of that had to be identified first. Demolitions and excavations, this is just a simple, idealised version of the site before the project started, and the light grey shaded buildings are the buildings we kept. The dashed buildings are the buildings that had to be demolished, and a lot of those buildings actually were porta cabins, so you lift them up and you grub up the foundations. Some of the buildings were adjoining old listed buildings, but the structural connection was almost non-existent. So really, I don't think the demolitions were that difficult. Probably the easiest part of the job. I suppose just to get into some of the detail and give you a flavour for the approach that was taken to temporary works and construction. This is the high school, which is one of the buildings we had to work around, and I suppose what you're looking at there was the levels had to drop under the level of the existing foundations on the high school, particularly at the northern end of the high school, because the requirement of the project was to bring a new basement level through up to 4 metres below the bottom of the walls as they were constructed. So there was quite an amount of underpinning, and you'll see just on this side here, these are old brick columns arched with arch supports between them. So with the contractor, we came up with a temporary works design to support the arches, literally hold up the wall, put in, these are permanent works steel beams for a new first floor structure. We put those in early because they gave us a temporary lateral bracing on the building, and we literally got agreement with the conservation officer and the city council to replace the brick piers in this building, and that allowed us to underpin the walls by means of making a new foundation under those piers, rather than trying to hold the piers in place and get a foundation under them and extend that, which, I suppose from the point of view of the health and safety legislation, we do try and remove a hazard, and I think we're legally obliged to try and do that where possible, given the constraints of time, money, and conservation issues in this case. But where we can remove the hazard, we certainly will take that opportunity because it makes sense, and that's a case in point here. There were various structural repairs needed to strengthen the old king post truss on the roof, and various other cracks that would have been part of the restoration of that building. Just a general shot to show you the level of excavation that had to take place, and some of the temporary propping that you can see there on your right. So that there was a good bit of care had to go into that, the whole construction sequencing there to make sure that was done right. Again, just some other general shots showing the propping, underpinning, using a lot of this is, I suppose, tried and tested traditional techniques for needling walls, holding walls up above where you want to put your new structure, and then traditional underpinning. The main school, which is the original building on the site, again, you can just see a bit of the scale. Like the original ground level is this line here, and we had to excavate down to, that's the bottom of the wall, and we had to go another maybe 1.5 meters or thereabouts to get down to our formation level. You know, you don't see these walls until you go at it, and that's something that it's just the way of life. And you're dealing with old buildings, until you actually build it, you're not sure exactly what you're going to find. So, you know, I think one of the secrets to it really is a high level of engagement with the contractor, so that you're constantly reviewing what you're finding, and you're progressing construction techniques that, you know, are buildable in terms of the program and cost, etc. And here you'll see there's this is a traditionally underpinned. I think a lot of this actually is some of the tanking. There's a basement in behind the other side of this wall, but we traditionally underpinned here using letterbox shutters in a hit and miss stage sequence to bring the walls down to a good bearing surface on rock. So again, tried and tested techniques in a lot of places there. One of the challenges we had in the design phase was to lower the level right in front of the old convent. Literally, that wall you're looking at there is an old, on the top picture, is an old random rubble gravity retaining wall, and it's located about 2 meters in front of a listed building. And the listed building isn't even bearing on rock, and we had to underpin the building as well because it's subsiding. It was subsiding before we started the job, just to clarify. But I suppose this was a quite a challenging part of the design, because it involved permanent and temporary works, and you know, if this wasn't done right, you're going to have a significant problem with a listed building just behind this wall. So just a couple of shots showing those anchors go into rock at about 15 degrees, fairly standard rock anchor system there, with a gunite mesh reinforced face on front of it. Those anchors are really there to stabilize the wall, and we found we needed to, you'll see there's some mesh at the bottom of this photograph here. We needed to get down. We were hopeful that this wall was all on rock, because the couple of trial pits we did showed it was, but when we got to do the work, there were areas where the rock had disappeared, so we were left with a problem area we need to strengthen to get down to rock. And once we got to good rock, we were able to just literally cut out the rock, and it was self-supporting. The architect's design required that we used every inch of the site really to get the square meterage we needed for the use of the site. That's a photograph showing this is the mesh reinforced bit in between the gunite supported rock anchored wall and the rock just below it. And again, the sketch here, you know, that shows the overburden, which is the light grey hatched ground at the top, and you can see there's no foundations under the listed building, and we're going about 4 meters down again, right in front of that old wall. So those rock anchors went in, and they were really only needed for probably 3 or 4 months, as the main building was built in front of it. Those walls are all in now, I think, David, at this stage. So like that wall is now propped in the permanent case by the main structure. So those anchors are redundant, but I think it was the only way to do it at the time. Ship's bow wall. It's not a great sketch now, but the top is a plan view showing an old masonry wall which stuck up out of the ground. I tried to convince the architects a number of times just to knock both of those walls you see in a V there, because trying to work around them was so difficult. They're about 6 meters, 7 meters high, and they're not stable. Just the shape and the position of those walls are not stable. And there's a third party. There's an old lady, Mrs. Conroy, lives on the north side of that wall. So it's not even our wall; it's a shared wall, and there was huge interest in keeping this wall, so we had to work around it. I'll show you a couple of photographs of, I suppose, how we did that. That's a view on the top. That's a view looking into the neighbouring property on the right, and this is the school side on the left. This is a view looking up from within the site, looking back up at the wall, and you can see, we had to keep this wall for aesthetic reasons, really. It serves no real function because we could have gotten rid of one side of that wall and had a much easier time battering back down into the site and even using a different retaining system. But the wall was kept for aesthetic and conservation reasons. And the way we did that was, I suppose, a combination of putting in permanent ties between the different leaves of the wall. You'll see a tie here. So we braced the wall, one wall off the other wall at an early stage. We reduced the ground level between the two walls to reduce the retained loads trying to push the wall apart. There was a significant structural cracks on our neighbour's side of the wall, over here on this side, which we structurally stitched using a spiral stainless steel repair bars. So we did everything we could to make the wall. I suppose the fundamental principle is everything you do, make it stronger, make it better before you start to go at it. So we did as much as we could do early days, and then proceeded to put in the rock anchors here along the bottom and also underpin the wall. So that wall was then stable to allow the significant excavation to take place right in front of it. Another part of the site where you can see this is the PE hall, which is a double height portal frame, reinforced concrete structure with fixed end connections at the bottom of the portal to bring the loads back down into the rock and the foundations. And you can see, when O'Donnell and Toomey first did their design of this site, there was no gap at all between this new wall and the old boundary wall. And it took me a bit of negotiation to get them to push it this far back, which is about 1.5 meters, David, I think, isn't it? Of that order, So, that was a very challenging part of the site as well. And the contractor used all his communication skills to get on with the neighbours and knock this wall down with a view to giving the neighbours and the school a free new wall. Again, if you have your health and safety hat on, it's the right thing to do. You take away the wall. We don't have to support it in a temporary case. Much safer for the guys building it, and the client and the neighbour gets a new wall for free. So fair play to the contractor for coming up with that idea. That's just a photograph looking at the wall, and you can see the scale of excavation right in front of that old masonry wall there. Another photograph looking down the slope. You can see Roach's Stores on Patrick Street there in the distance, and this is the area where the wall was removed in here, and you can see, and that's another photograph of the same slope. It just made construction a lot easier. Retained buildings, I suppose this is just a general view showing the typical type of intervention. There's a new basement where this little mini digger is here. There's a new basement structure going in. It's probably got another metre or two, probably 2 metres to go down before we link into the front of the old main school there. So again, a lot of intervention and carving out new openings and propping and supports. And then the photograph at the bottom, just a general view again, that's the old main school on my side on the left, and this is the new arts block. And the architects wanted the new clean concrete, completely unblemished, finished surface building to come straight up against the old stonework, so you had a contrast. And there's just a very, very small joint between the two, but they're completely separate structurally. Just a few general shots. That's the main school from the front in the middle there, and from behind you can see how slender and tall that whole building is. The building just on this side, just from here across, that was demolished. That wasn't part of the listed, the curtailment of the listed building. So that was demolished, and we've built in and wrapped right around on 3 sides with our new buildings around that building. There was listed stairs had to come out, and new floors went in, and strengthening of existing floors and assessment. The assessment of the old the old floors is interesting because these buildings were built using very strong hardwoods that used to come up the river, and we've done a lot of old buildings around Cork, and actually the strengths you can get out of the timber are way in excess of your C16 and even C24 timber. So, and the timber is in excellent condition. So, it was actually very easy to work around the older elements of the buildings. Then we found some of the more modern interventions were in a poorer condition than some of the older elements. And I think there's a lot to learn there in terms of the old trades and how they used to do their work. The high school, just a general view again of this, the top picture is a view looking down the western boundary of the site, and that's a listed facade. So anything we did had to treat that very, very carefully. But it's in very good condition, and really I don't think that needed any structural improvement at all, that wall. It's absolutely fine as it is and always has been. Again, a testament to the original builders. The other photograph is just a general view showing the new first floor beams as we saw earlier. An awful lot of intervention. The greyed out area at the bottom, or the purple at the bottom of that, shows the extent of that wall that had to come out for the architect's design to be realised. So it was a very challenging project, and all of that element of the work is complete now and has successfully been completed. The convent, just a general view. We had to underpin the convent. You can see the cracks there over the window. That wall is the southern facade. So the rock anchored wall is 2 meters in front of that wall, the one we were looking at a while ago. And you can see the wall was already in trouble before we started. So we included traditional mini piles through the foundations as part of the project. The Gate Lodge, that's just a small building at the front of the site. We had that's a section along Patrick's Hill, and we had to remodel the footpath to get the new entrance to work. And there was a lot of discussion with the city council about building regulations and slopes, etc. We couldn't meet Part L everywhere. We're out in a hill that's 1 in 4. So they just had to be convinced that until you drove into the car park, the new car park, like from the new car park into the school, that was Part K compliant and Part M compliant. But the minute you came to the gate and came out, we just couldn't meet those requirements, and they had to accept that. The PE hall, it's a reinforced concrete portal frame with exposed concrete finish. This is the architect's image at the bottom. This is our interpretation at the top. There's a new AstroTurf playing pitch on the roof with high level protection netting around the roof. So that'll be an interesting place for the girls in the future to play their sports, looking over the city. We incorporated netting, lighting onto the netting posts as well. This is just a general view of the PE hall construction, showing the level of scale there, very close to the boundary wall. It's a fully monolithic construction, so all of the loads come straight back into the haunch and down the face of the columns into the rock. So we're trying to get as much load, use the rock to get advantage out of it, to take high bearing pressures and bring the loads around the structure into the foundation. Science Block is probably the biggest building on the site. It sits pretty much in the middle of the site. You can see there'll be shots in a minute showing the large excavation needed for the main access block here on my side of the slide on the left, and then 4 stories of new framed in situ concrete building. Typically there were very large windows to get the light required for the design and to meet the department's requirements for light, and that means you have very little wall left by the time you're trying to get that much light into the building. So we used upstand concrete beams where the soffit of the slab would be the head of the window, and then the beam, the upstand beam would come up to the windowsill of the next level, and that was your load-bearing element carrying the loads and the dead loads around the outside edge of the building. So there was no other structure other than exactly what the architect needed. Just a couple of other views of the science block, just I suppose to give you a sense of the layout. I won't go into that in too much detail there. The arts block was a building at the back end of the site, adjacent Mrs. Conroy's property. You can see there's piles on the left-hand side for the single story. Now the piles aren't there for weight. There's no real weight on those piles, but we were just concerned about differential settlement, so we kept it fairly simple. You're either on rock, you're on lean mix on rock, or you're founding on piles, so that you're not getting differential settlement. So the upper two steps there were piled, and then we were down into ground rock bearing foundations from there on. That was the only part of the project that was piled. Just general views of the arts block. You can see how close we were to the neighbouring property here, and as part of the agreement with her engineer and her solicitor, we got early access to her house, and we agreed the scope of works with her engineer. There was a couple of, improvements needed to the shared boundary wall. We got those done early, and there was a very good relationship, really, with that neighbour and all neighbours to date, thankfully. This is just a general view of one of the high-level walls in the arts block, and you can see the depth of excavation. I mean, the top of the rock excavation is just here, and it's dipping at maybe 80 to 70 degrees. And David will talk in a minute about the whole approach they took to the construction of these high-level walls. Where you're very close to an excavated edge. I mean, the rock was getting quite hard at that part of the site because it was the deepest excavation on the project. That's just another general view of the basement construction, just to give you a sense of scale. Okay, thanks very much. I hope I haven't gone over my time. I'm going to hand over to David. Thanks a lot.
Good evening, everyone. My name is David McCarthy, and I'm working for L&M Keating, and I'm the project manager on the St. Angela's job in Cork. I suppose my presentation this evening is mainly to give you an insight into the construction stage of the project. John has gone into detail on the design stage. I want to give you an insight into some of the challenges we faced at the construction stage. My overview of my presentation, I want to give you a little introduction to who L&M Keatings are. We might have worked with us in the past, some of you, but just give you a general overview of the company. I want to talk about the initial challenges we faced in St. Angela's, some of the key engineering elements. I'm going to go through the conduit retaining wall, getting the concrete over the line. I'm also going to look at a few case studies looking at some of the key RC elements. So L&M Keatings, we're a building and civil engineering contractor. We're based in Kilmihill, County Clare. We also have a regional office here in Dublin. The company was started up in 1987 by Louis Keating, who is a fellow of the Institute of Engineers. We're operating in Ireland and the UK, about 80 direct employees, and turning over the order of 40 million and continuing to grow. The main sectors in which we're working are the building and civil engineering contracting. That would be the core business. But we also have plant hire company, which is specialising in some specialist plant, particularly plant related to marine works. And then we also own and manage a number of marinas. I've just put up a visual to give you an idea of the geographical spread. To give you an idea of the geographical spread of our work throughout the country. As you can see, we're working in all corners of the country. I think there's only one county in Ireland that we haven't carried out a contract. And now back to St. Angela's. So to talk about some of the initial challenges that we're facing. Okay, the obvious, the persistent challenge that we face up there is the location. So as you can see from the photograph here, this photograph is taken just outside the Opera House in Cork. So you can see it's a city centre location and it's looking southwards down over the city. And with that city centre location comes a number of obstacles. One, the traffic. It's the only entrance is on St. Patrick's Hill, so which is quite busy during rush hours, so you have to consider the scheduling of deliveries and concrete pours. And also, because it's a city centre site, the site has been essentially fully utilised by the design team. So there's a very limited amount of space on the site which isn't occupied by structure of some kind. So that leaves very little space, if you like, for the contractor for storage, lay down, and working area. In fact, we've had to use part of the permanent works. We've used the roof slab of the PE hall as a temporary lay-down area and work area. So we've gone through some temporary works designs to improve the load-bearing capacity of the north section of the roof and using it for storage then after that. Access is from St. Patrick's Hill only. It's actually too tight for Arctics. We can't get any Arctics onto the site, which does cause numerous problems. In particular for the reinforcement steel. All the rebar it's bent in Dublin by our supplier. It has to be transported by Arctic to Cork, transferred at their depot to rigid trucks, and then brought onto site as required. There you can see a photograph of the site entrance. This is the main entrance to the site, through which all materials and plant are brought, and it's less than 4 metres wide. The gradient of the road of St. Patrick's Hill itself is must be one of the steepest thoroughfares in the county and probably in the country. The gradient at the site entrance is in the order of 1:4, which has created a lot of problems, particularly for concrete delivery. If you could actually get a full concrete truck up the hill, like a concrete truck would normally be carrying in the order of 8 metres of concrete, it would actually flow out the back of the truck. So in this situation, the max load that we can take is about 6 metres on a truck. So there's a visual showing the slope of the hill. We're also bounded by private residences and schools, which causes difficulties from the point of view of noise and vibrations. There's a high pest factor, if you like, in continually rock breaking and creating noisy activity on site over several months. There was a prolonged stage of rock breaking on the site. So we are very grateful to our neighbours that they have been patient with us. But we have made concessions also, particularly to the schools. There's about 5 or 6 different schools within a stone's throw of the site. So during exam periods particularly, we have made concessions to suspend very noisy work to more suitable times. The topography of the site is steeply sloping, as John has elaborated on earlier. There are in fact 5 distinct formation levels in close proximity, so there's essentially shelves cut into the side of St. Patrick's Hill to take the structure. And the proximity of these various formation levels means a requirement for a lot of retaining structures between these formations. I'm just showing a section here which John probably has shown earlier. Apologies for a bit of duplication, but I'll try to concentrate on the construction element if possible. This is a section cut north-south through the site. So down the left-hand side you can see the south end of the high school with its ground floor level at level 1, and then up at the right-hand side we're looking at the north end of the arts block. And the formation level up the north end is at level 5. I've just marked up a plan to give you a rough idea as to the extent of the various formation levels. So you can see they're marked with different colours. The blue level 1, red level 2, green level 4, yellow's level 5. And the zones where these various formation levels meet are essentially the zones where we have the larger retaining structures. Talking about the geology of the site, John has gone into the site investigation. There was approximately 7,000 cubes of material to be excavated and removed from the site. A large proportion of that material was rock, about 50% of it was rock. The rock was, as John described, moderately strong siltstone and sandstone, and that's what was borne out in construction stage. That was the type of rock we were encountering. So there's a photograph just to show the excavation almost complete for the science block and PE hall. The multidisciplinary nature of the project also posed a challenge to us, particularly in, I guess, trying to put together a site management team that had sufficient experience and depth and breadth of knowledge to cover all the various aspects of construction related to the job. For instance, we had to refurbish 4 listed buildings. There you can see some of the temporary works for the replacement of the piers in the high school that John has gone through earlier on. There you can see on the left-hand side some of the existing stone and brick piers, and on the north and the right-hand side the piers have been replaced with RC. We've also had to look at undertake large earthworks and rock breaking operation. There's a photograph of the rock being removed from the PE hall, and you can see the soft dig as well taking place. Substructure works, there's been piling, rock anchoring, basements to be constructed and tanked. And there's a photograph of the completed piling up at level 5 of the arts block. We've had specialist retaining structures, such as the convent retaining wall, which was rock anchored and shotcreted. You can see just an elevation of the completed retained wall. We've also had to develop a number of temporary works designs. These have had to cover supporting existing buildings, cantilevered scaffolds, and RC falsework. Here's a typical example of a temporary work design. This was done for a scaffold to the west elevation of the high school. In this situation, this building is bounding a public road, and the road was too narrow to allow us to hoard off and build scaffold from the ground up, from the road up. So we had to cantilever it out through windows on the upper story. And there is a photograph of the scaffolding in place, or partly in place at least. Large in situ RC structures made more difficult by the high quality fair-faced finish that was demanded by the architect. Apologies for the quality of the photograph here, but this is essentially a photograph of a typical corridor. So you can see we're looking at fair-faced concrete to the wall, to the soffit overhead, and you can see in this situation we've an in situ RC bench as well, which is also completed in fair-faced concrete. There was 2 number steel bridges which had to be clad in Iroko joinery and zinc. These are steel framed, and this is one in place under construction between the arts block and the convent. And there was also a rooftop astropitch, which John has spoken a little bit about. And there's an architect's elevation of that. You can see the 7-metre high fencing and netting that has to be constructed around that pitch. And there's just a steel shop drawing to give you an idea of the structural framework required to support that fencing and netting. So moving on, I just want to talk about a couple of key engineering elements. Again, this one John has gone through in some detail, but I'll just talk about it from the construction perspective. This is the retaining wall in front of the convent. This is a section through the temporary works design, which was a possible temporary works design suggested by Malachy Walsh. So you can see the anchors, and you can see the double height basement which has to be excavated directly in front, just 2 metres in front of the existing convent building. Here's a photograph which just indicates what we were dealing with before we started works in this area. So you can see there's an existing stone wall about 3.5 metres high in front of the convent at this stage. We then had to come along with a drilling rig and install rock anchors along the wall. This was followed up by mesh was put in position, tied in position. And then the wall was shotcreted, and there was plates and nuts fitted in position to stabilise the whole structure. Once that was completed, we could then proceed with phase 2, which was to dig out the rock the rock underneath the wall to take the formation level down another approximately 2 metres below the bottom of the shotcreting. And once that was completed, we were able to install the rock anchors again to help stabilise the entire area. And that was then again shotcreted. So once that second phase had been completed, and you can see the completed job here, what was being retained and the convent above was essentially deemed to be stable at that stage. So the temporary works were effectively doing what they had to do at that stage. So, and it was also agreed that the quality of the rock we were meeting at the foot of the retaining wall at this stage was of a good enough quality that we could just continue to take down the formation without carrying out any further retaining works. So here are just a few photographs showing the works that had to proceed after the rock had been stabilised. Here we're back blinding for the base of the science block slab, which has to be installed just in front of the convent wall. The tanking then proceeds underneath the slab. You can see the convent wall there in the background again. Then steel fixing. Then we pour the slab, and the final step here really in closing up the temporary works was you can see the shutters in place at the base of the shotcreted wall in order to install the back blinding, which essentially encases the bottom of the mesh and finishes up that section of the works. So a key engineering element on the project is the reinforced concrete. And before we could go ahead and pour and construct any of the RC elements, particularly the fair-faced RC elements, we had to get a couple of things over the line. First of all, we had to get a concrete mix design approved. And this had to satisfy both the engineering and the architectural requirements. So the engineering specification called up for a C35-45 concrete. It looked for 10 mil max aggregate size, specified the GGBS content, it specified the water cement ratios, and there was no real difficulty in finding a supplier to provide a concrete to match the specification. The real difficulty, I guess, was trying to satisfy the architectural specification. So the architects, who were O'Donnell and Toomey, required that we, and set out in their specification, that a colour sample for the concrete which they held in their office in Cork be matched by the proposed concrete for the project. So they wanted a concrete that was bright, essentially. They didn't want a dark grey concrete, they wanted something as bright as they could. So they had a colour sample in the office, and they wanted the proposed concrete to be at least as bright as what they held in the sample. So we then went to the various suppliers that we were dealing with at the time to try and get some samples of what they were able to produce. And in the architectural sample they had contained beta carb, which is an additive, essentially a lime filler, which was added to the concrete to essentially brighten the colour of the concrete. Now this is an expensive additive, if you like, and we were hoping to not have to use it if we could. So we were able to come up with a mix which was an all limestone mix. And the unique thing about this particular limestone mix is that it used a crushed rock sand. So some all limestone mixes still use washed sand, which still doesn't give you the same level of brightness. But essentially with this mix, you're essentially adding lime dust to the cement paste, which really bears out the colour in the finished concrete. So we were able to agree on a concrete supplier, and we were then able to submit a concrete mix design for approval. Then we had to get agreement on samples of the fair face finish. So the architects again have called up their finish, the type B finish. But they've also called up, there's an addendum concrete specification in the works requirements, which calls up other parameters that have to be met by the finish that we have to provide. So we had to then provide 3 or 4 different samples of sections of walls, of fair-faced walls, for the architect to approve. And the elements they're interested in is the sharpness of the concrete, that there's no blowholes, the quality of the concrete around the tie holes, and they want to look at the construction joints that we're providing and so on. So once the concrete samples were approved, we then go on to the formwork drawings. So part of the architectural specification again required that the contractor should provide formwork drawings showing all elevations. So essentially we had to mark up all the wall elevations to show the plywood layout that we were proposing for the formwork, because that plywood layout would be seen on the finished concrete, as would the tie holes. So this is a typical example. This is the atrium wall, which is the feature wall on the job, and it shows in red the outline of the pattern of the plywood, and in green you can see the locations of the various tie holes. So this is the type of thing that has to be submitted and altered and agreed with the architect for each wall. So once the formal drawings for a particular element were over the line, we could then go ahead and start pouring concrete. So I wanted to just take you through a couple of case studies now in relation to two of the RC elements. The first one here is the atrium wall. Like I was saying, this is the feature wall on the job. It is in the order of 10 metres high, and it's about 20 metres wide. Now, it's located, as you can see here, between the PE hall and the science block basement. This is the architect's elevation of the wall. It's, as you can see, it's about 10 metres high. Now, initially when we looked at the wall, we weren't considering pouring at 10 metres because we thought we'd have too much difficulty in trying to place concrete for that high wall, particularly when there was such a high requirement on the quality of the finish. Placing concrete in a 10-metre shutter is not that straightforward. But if we didn't do it in a full pour, you would then have to introduce horizontal construction joints or vertical construction joints across the wall. And as it is the feature wall of the project, we decided we best, after assessing it with our subcontractor, we thought the best route was to just try and do the whole lot in one pour, which wasn't without its risk. So the first thing we had to do then was develop a temporary works design for the 10-metre high wall. The part of the temporary works design that was of most interest to us was the spacing that was required between the ties and the concrete. So the plywood layout sets out, if you like, the spacing for the horizontal ties. The ties are located at the centre of each of the sheets, so they're 12-20 spacings horizontally, but vertically it was the temporary works design which was setting out the spacing. So once we knew there was 1100, that was the design parameter, we could then revise the formwork layout to show that. So again, this was agreed with the architect before the works proceeded. Here is a sketch that was done at construction stage, and it's just basically highlighting the various horizontal and vertical elements that are tying into the atrium wall. So there's a number of slabs, walls, landings that have to be accommodated by introducing conibar into the atrium wall. So conibar is cast into the wall to accommodate these elements. So here you can see this is the main shutter for the atrium wall. It's about 10 metres high, it's about 20 metres wide. We also poured a 7-metre return on the right hand side of that. You can't see it in that shutter, but we thought it was best to do so in order to help stabilise the finished wall rather than having a structure of that size and having to temporarily prop it. So once the conibar was put in place, we were then able to proceed with steel fixing. And there you can see some of the propping for the shutter to hold it in position. This is the south side of the shutter being closed up, and this is now ready for concrete. So after that, we were able to proceed and pour it. It was poured with a concrete pump and using a 9-metre tremie pipe. And thankfully we were able to get a good quality finish. I'm not sure that the photographs represent that or represent the wall very well, but we were very pleased with the result we got on the finish in the wall. So that's it from the north side. And that's it from the south side, from the PE hall side. The next case study I just want to go through is the single-sided wall shutter system. So essentially there's two ways which we can construct walls, particularly ones retaining walls. Either the double-sided walls, which I've just gone through, or in this situation, a single-sided wall. This particular wall was located on the north side of the science block basement, so it's immediately opposite the atrium wall. And this is a section through the wall. It's retaining it's about 5.5 metres high, Now at this stage we had two options. We could go with a double-sided wall if we wanted to, but that would involve excavating about 1.5 meters or thereabouts of additional material, and the material in this area was hard rock. So we wanted to keep the excavation to a minimum. So we decided to go with a single shutter system instead. So the next step was to complete a temporary works design for the shutter system. And here you can see the key element of the temporary works design that we were interested in was this anchor down, that you can see it highlighted down the bottom of the wall. So that anchor is cast into the in situ slab, and that essentially restrains the entire shutter. It prevents it from sliding and overturning. So it was key that those were put in correctly. And you can see here those anchors actually installed. They've been cast in with the base slab. So just before we could get to that stage, we had to first back blind the broken rock face. So once the rock face had been excavated sufficiently, we positioned the shutters and then poured concrete between the shutter, this one-sided shutter, and the wall to provide a smooth face, an even smooth face for insulation, a drainage layer, and tanking. And you can see the blue insulation, you can see the tanking system being fixed to the back blinding. So once the insulation and the tanking are complete, we're then able to proceed and steel fix the wall. Again, we have connie bar to be positioned for landings. This is actually, this zone of the wall is a stairwell, one of the main stairwells in the project. So this connie bar is making provision for the landings that will be connected to that wall. After that, the single-sided shutter system can be put in place and bolted up, and at that stage we're ready to pour the concrete. Once the shutter is poured, so this is the end result. You can see on the left-hand side we have a non-fair face finish was required in that section of the wall. It's going to be clad in plywood afterwards, but on the right-hand side there was a fair face finish called up for that. And you can see, just going to zoom in here on the finish. You can see a blue bloom that occurred once we struck the shutter. And this was a big surprise to us at the time, because this was essentially the first fair-faced concrete element we poured on the job, and it was critical to get it right. And when we saw this bloom or this staining, we didn't know what it was at the time. But we got some advice. I see Henry Kerr in the audience there, and we were talking to the Irish Concrete Society at the time. And this is a phenomenon that occurs with high GGBS content concretes, and it was probably accentuated by the fact that the other side of the wall was heavily insulated. But it's a phenomenon that goes with that type of concrete. It has happened to us periodically through the job, but in this situation, the staining, and it generally does just fade back after a number of weeks. And I'm happy to report this did too. That essentially concludes my presentation. I'd like to thank you all for your attention, and thank the Institute for having us here. And if you have any questions, I'll be happy to take them after this. Thank you.